Check 1, 2, 3. So today we are going to continue our concept on the rate of reaction, and we're going to go into the last topic of the rate of reaction. Today we are going to discuss about the interpreting data, especially graph. Okay, now let's start from the raw data that we have. So far, we've discussed into two types of following the rate of reactions. The first part is when we have the gas collection, in which we are going to have tables of the time and the volume of gas. And the second, we're going to have the gas escape, okay? And then we're going to have the mass loss. In this case, what we're going to have is, over time, what was the mass of the reaction vessel. Okay, now, first thing to do is we need to plot the graph into data point. Okay, the time will always be on the x-axis, and the other item is going to be the y-axis. So it's y number 1, y number 2, y number 3, etc. Now, when we are going to get the data, we are going to have them on the time. Okay, and let's start with the gas collection. It's going to be the volume. A gas volume is going to initially, they are going to be high. This is the typical condition of gas reaction. If you are doing correctly here, we are likely to see something that is initially up, and then they're going to decreasing the rate until finally 0. Now let's see what is the meaning of the rate of reaction. The rate of reaction is going to be taken as the change over time. Change of volume over time. Generally, we are going to measure this over several intervals. So imagine we're going to cut this graph into several parts. The change of volume will be what is the difference between this part here over difference of the other part. So this is the change of volume, and here's the change of volume. As you can see here, if you put the time equal, the change of volume is going to decrease over time. Initially, it's kind of high, but over time, they're going to go down, and in the end, it's going to be totally 0. It's going to be initially high, decrease over time, and then last is going to be down to 0. When, with sufficient time, we don't see any other change, we say that the reaction stops. I repeat, when over sufficient time, we see that the volume is no longer increasing, we say that the reaction stops. So again, the graphical interpretation of the rate reaction is the gradient of the curve. Over time, the reaction is going to decrease over time because the reactant is used up. Why did the reaction stops? Because all the reactant has been used up. No more reactant, no more reaction, rate is 0. So this is how we find rate of reaction from the graph. Next, we're going to see effects of factors on rate. The first is, what is the effect of concentration? Let's say this is the graph, the initial graph. If you are using a concentration that is higher than normal, what do we get is a reactant who's going to react faster. But in the end, the weight is going to be the volume, it's going to be the time. But in the end, we're going to have the same amount of product. So they're going to initially go faster, but in the end, they must have exactly the same total amount. So they're going to start steeper, but then ends at same level. They will not go higher unless we use more reactant, nor do we go lower unless we are using less reactant. Of course, if you're using lower concentration, this is for higher concentration here. If you're using lower concentration, the graph will be less steep, but they're going to end up in the same position. Something like this. There's going to be lower concentration. Again, in lower concentrations, you must end in exactly the same total amount of volume. But we are going to start less steep and same amount in total. This is the effect of concentration. In fact, this is going to be the same shape we're going to have for the three effects. This is going to be the same with concentration, or the surface area, or the temperature. All of them is going to have the same effect here. They're going to go faster initially, but we're going to end up at exactly the same position in the end. So higher concentrations or surface area or temperature. By the way, how do we have surface area? We can have surface area if the particles are smaller. So powder will have more surface area than lumps, for example. Okay, now, how about the effect of rate on using catalyst? The effect of using catalyst will be same with the effect of increasing concentrations or surface area or the catalyst. So the one that is higher, this is the same if you have higher concentration or higher surface area or higher temperature or higher using catalyst. We cannot go lower if you're not using catalyst. So if you're using catalyst, it's going to be higher than initial. That is how we interpret data. That will be it for now. Thank you very much.